Hey guys, we're in section 11.5 still, and we're talking about multiplying matrices. So, how do we multiply matrices? Well, assume we have a matrix A and a matrix B. You can only multiply two matrices if the inner dimensions of the matrices match. So, remember that we define a matrix by its dimensions. So, this is the amount of rows it has, and this is the amount of columns. Right? And so you can only multiply a matrix A times B if the columns of the matrix on the left is the same as the rows of the matrix on the right. So if we're multiplying A times B, the 1 and the 1 match, and so that we can multiply them. And the resulting matrix is actually the values on the outside. So when we multiply the 2 by 1 matrix A times the 1 by 2 matrix B, the resulting matrix AB is a 2 by 2 matrix, which basically means 2 rows and 2 columns. And how do we figure out what these values are? Well, what you're doing is you're taking the first row of column of matrix A and the first column of matrix B, which just happens to be one term, and you're multiplying them. And that's the term that goes in there. And so what's the term that goes here? Well, notice this is the second row, but the first column, right? And so you're going to take the second row from matrix A and multiply it to the first column of matrix B, which is just the term B11. Okay, so let's fill in these last two. This is the second row, this is the first row still, right? First row, second column. And so you take the first row, which is just the term A11, and you multiply it to the second column, which in this case is B12. And this is the second row, second column. So you take the second row from A and you multiply it to the second column from B. So this is kind of like the simplest version. What happens when we have to do more than one multiplication? Well, to find the term inside, you actually have to start adding terms together as well as multiplying them. So the resulting entry in a new matrix that you're creating due to matrix multiplication is a linear combination of the ith row of matrix A and the jth row of matrix B. So essentially all this means is that you're taking the second row of matrix A and the third row of matrix B. That's going to reference the second row of matrix AB and the third column of matrix AB. But we can just do some examples because it'll explain it a little better than being so abstract. So the first thing we have to do before we multiply matrices together is make sure that we can even do it in the first place. So let us define these matrices by their dimensions. How many rows does this matrix A have? It has 2 rows and 1 column. B has 3 rows and 1 column. And C has 3 rows and 2 columns. So can we multiply the matrix A times B? Well, the matrix A is a 2 by 1, right? And the matrix B is a 3 by 1. And since these two terms do not match, you cannot multiply these. So you cannot perform this operation here. Likewise, for A times C, you have a 2 by 1 times a 3 by 2. And once again, the interior numbers don't match. The columns of row A do not match. The columns of matrix A do not match the rows of matrix C. And so this is also not a valid product. Let's check C times A. The matrix C is a 3 by 2. The matrix A is a 2 by 1. And so now we have these inner numbers match. And so the resulting matrix is actually going to be a 3 by 1. So 3 rows and 1 column. So let's go ahead and do that product together so we kind of get a sense of what it looks like. So the matrix C is 1, 0, 2, 4, 3, 0. And the matrix A is a 1, 2. So to get the matrix CA, which we know is a 3 by 1, right? There's going to be 3 rows and only 1 column. We have to notice that this, okay, so what does this look like? This is, I'm just going to call it Z, but it's the Z, it's the first row, first column. This is the second row, first column, third row, first column. And so the matrix on the left, the first number corresponds to what row you're going to grab, and the second number tells you which column you're going to grab from the second matrix. So since this is row 1 from C is actually, so Z11 is actually the row 1, 0, and I'm going to multiply that to 1, 2. And so all you have to do here is 1 times 1, and always plus 0 times 2. So let me be more explicit about that. It's that first entry in row 1 times the first entry in column 1. And linear combinations that we talked about before just means adding everything together. The second entry in row 1 times the second entry in column 1. And so this is just going to equal 1. And so in our first spot, we're just going to put a 1. Okay, what is Z21 going to look like? Take the second row from the first matrix. That's 2, 4. Take the first column from the second matrix. Since A only has 1 column, it's always going to be the same. So we have 2 times 1 plus 4 times 2. And what is that going to look like? Well, it's 2 times plus 8. And so the value is 10. So we're going to put 10 in the second index. And so what does Z31 look like? The third row from the matrix on the left, which is 3, 0, and the first column from the matrix on the right, which is just going to be the same column we've taken for all the other ones. So we have 3 times 1, because it's the first entry in row 1 times the first entry in column 1, plus the second entry in row 1 times the second entry in column 1. So we get 3 plus 0, which is just 3. And so the product of C and A is the 3 by 1 matrices, 1, 10, 3. So we'll do one more example, but one thing I want you to notice is that C times A was this matrices, but recall that when we tried to do A times C, we couldn't even get a value. We couldn't get anything because it's not allowed. So matrices are the first thing that you guys get exposure to, where A times B does not necessarily equal B times A. Because with numbers, right, whether you do 3 times 2, you get 2 times 3, and 3 plus 2 is 2 plus 3. But with matrices, under multiplication, the commutative property doesn't hold. And we can see it right here because we took A times C and we couldn't even get a value. But when we did C times A, we got this 3 by 1 matrices. Okay, so that's just something to be aware of. And let's do one more example. So let's say we have the matrix 1, 2, 3, 4, 5, 6. And then we have the matrix. So this is a 3 by 2. So let's do a 2 by 4. So 1, 2, 0, 1, 0, 1, 2, 3. And so do the numbers on the inside match? Yes. So our resulting matrix is going to be a 3 by 4. And so we're going to have 3 rows and 4 columns. And let's see what those values are. So we have 3 rows, 1, 2, 3, 4 columns, 1, 2, 3, 4. Make this line straighter. Okay. So what is going to go in our first row, first column? Well, to see what goes in our first row, first column, we need to take the first row of the matrix on the left and the first column of the matrix on the right. We multiply the entries that are in the same location. Like this is the first entry, this is the first entry, this is the second entry, this is the second entry, and so we're just going to multiply those terms and add them together. So this is equal to 1 times 1 plus 2 times 0, which is just 1. So that's what goes here. Now we're trying to fill out what goes in the first row, second column. So we take the first row and the second column, and we do the same thing. So 1 times 2 plus 2 times 1, which is 4. So that's what goes here. Okay, now we're trying to see what goes in the first row, third column. And so the first row, what's the third column? Well, it's 0, 2. And so this is going to equal 1 times 0 plus 2 times 2, which is also 4. Cool. And then for our last of the first row, it's first row times fourth column. And so what does this give us? This is 1 times 1 plus 2 times 3. And so it's 1 plus 6, which is 7. Okay. Now let's split this up and do it over here. Now we're looking for the second row, right? The second row, the first column. So the second row is 3, 4, and the first column is 1, 0. So 3 times 1 plus 4 times 0. So we get 7 here. The second row times the second column. And hopefully now you guys are kind of seeing the pattern. 3 times 2 plus 4 times 1. And so 4 goes on here, right? So let's just jump to this one and see if we can figure out how to do this one. This is the third row. So what's the third row? It's 5, 6. And we want the fourth column, right? And we're still going to multiply entry by entry. First entry times first entry plus second entry times second entry. So 5 times 1 plus 6 times 3. This is 18, this is 5, and so we get 23. And so that's what goes here. Okay, so that's how you multiply matrices. And it's important to note that we said before that these are not commutative. We're going to stop the video there, and I'll see you in the next one.